Hello, everybody, and a warm welcome to this lunch webinar on artificial intelligence and the future of work. I'm just going to do a little bit of change there. My name is Maria, and I work as Alumni Relations Manager here at Lund University. And we are cooperating around this webinar with our colleagues who are in charge of the MOOC, the massive open online course provided by Lund University about artificial intelligence, business, and the future of work. And I'm soon going to hand over to our main speaker, Anamaria Dutceac. But first, I'm just going to give some quick housekeeping rules about this webinar. It's lovely to see that so many of you logged in. If you have any questions, feel free to use the Q&A function that you find on the bottom of your Zoom window. Please use that and you use it from the very beginning of the webinar, and we will have a Q&A session at the end after Anamaria's talk. Also, as you can see, this webinar is recorded, so we will send you a link to the recording by email afterwards. You can watch it over and over again. I have here in the studio in Lund, we also have my colleague Karen, who's also going to help us with the Q&A and also provide any links that are important, for example, for the MOOC. And also if you're an alum and haven't registered for the Alumni Network yet, you will also get the link there. But without further ado, it's my honor to hand over the screen to Anamaria Dutceac, your senior lecturer at the Department of European Studies. The screen is yours. I hope everyone will have a fruitful session.
Thank you very much for the kind invitation to meet our alumni and present one of the topics that has occupied quite a lot of my pandemic time, namely the creation of this MOOC on AI, business, and the future of work. In the presentation that I will give today, I will focus on this question in a very broad sense. And of course, at the end, I will be very happy to answer some of the specific questions some of you may have, and also to talk more about the MOOC itself if there is interest in that. I will not say anything more. If I can share the screen, that would be great, because then I would be able to show you my presentation. Let me see if that works. Yes. So there we have our presentation, and let's see if you guys can see it. I hope it is visible. So we're basically looking at first question: what is AI? Yeah. And the term artificial intelligence has been known to cover all sorts of things, and most of the time it's been influenced in the public mindset by our consumption of popular culture. In an opinion poll made across the OECD, a lot of the people, when asked to, when were prompted, what do you think AI is for you, often associated the term with robots, and in particular with the Terminator, which is a movie in which Arnold Schwarzenegger played a non-human android-like being. Yeah. And obviously, I think people already in the room today would probably know that this is not the type of AI we're looking at. The question, nevertheless, is what is AI? If it's not Terminator, and if it's not just a robot, it's particularly a humanoid robot, what is artificial intelligence? And I think this is something that I don't know, you guys can see my screen? I think I got a question in the chat that the screen looks black, and I just want to make sure that you see my beautiful pictures that I wanted to share with you.
We see your screen, Anamaria.
Okay.
So
perfect.
Yeah, maybe
just wanted to make sure that you get to enjoy. Excellent. Thank you so much, because it's a funny picture. I don't think any of you have seen such automata. These two are two examples produced by a watchmaker, obviously a Swiss watchmaker and inventor called Pierre-Jacques Droz, who in 1768 designed the writer, which you can see here, performing the unimaginable task at the time, again in the 18th century, to write 40 characters with the pen on a sheet of paper. And of course, today we're looking at these automatons, at these robots, and we would not necessarily think they are intelligent, right? They're not, this is not artificial intelligence. And the question is why? And the reason why we think this is not what we mean by AI is because they lack a particular feature of artificial intelligence, and that is autonomy. Intelligence implies autonomy of thought, the capacity to reason independently. And that's what artificial intelligence ambition is. The researchers dedicating their time to design such computers, software and computer hardware have the ambition to build computers who could think autonomously, just like humans. Yeah. And here we get into the details of the superintelligence versus weak intelligence. The superintelligence machine would be the ones that would truly rival humans in terms of their capacity to process information and also the capacity to be creative. Whereas the intelligence that we're defining as artificial and we work with today, and the thing that I'm going to focus for the rest of my presentation, falls under the category of weak AI. And of course, it means weak in the sense that it is not as autonomous and is not as sophisticated as this imagined super intelligent machine. So what it means is that the computers can perform quite well, but only in a specialized arena or using a specialized, reduced in size set of tasks. Yeah. And this is basically something that I think it's important to keep in mind. And I wanted to basically finalize this historical introduction to AI with a beautiful quote from a major European philosopher, René Descartes, known for his rationalist approach to thinking. I think, therefore I am, the famous quote. He also had an opinion about the artificial intelligence, and he said this in 1637, so again in the 17th century. He talked about what we call today the AI paradox, the fact that AI models have excellent specific problem-solving skills, but they don't display any intelligence. And Descartes said the following: even though such machines might do some things as well as we do them, we humans, or perhaps even better, they would inevitably fail in others, which would reveal they were acting not through understanding, but only from the disposition of their organs. In organs, we can say the disposition of their code. And I think this was a quite prescient quote from René Descartes, 1637, just to give you an idea. I think it's quite an impressive, power of imagination, if nothing else. So we established then that artificial intelligence in today's world is correlated to what we call weak AI, in which computers, machines are powered by algorithms who have a degree of autonomy and can perform some specialized tasks without human supervision, but that we are far away from this comprehensive super intelligence imagined in sci-fi literature or films. And that leads me to what is an algorithm, because algorithms are essentially what we are talking about when we are looking at artificial intelligence. So we're not necessarily looking at embodied robotic intelligence, but as these lines of code. So algorithms are basically lines of code that try to calculate using logical mathematical reasoning and statistics, probabilistic statistics of various kinds, a certain outcome based on a certain amount of data. So the algorithms are basically the skeleton upon which all the other applications of AI are built on. Algorithms can be programmed in numerous languages, in numerous computer languages, and can have various degrees of interoperability. For example, if you write in R, your algorithm can talk to, let's say, to another algorithm written in Python or written in Julia and so on. So these algorithms are installed on hardware. So this is the software part of artificial intelligence, this algorithm section. These algorithms have to work on the basis of some hardware, which means the actual machines, the processors, the nuts and bolts, if you wish, of computers. And this is where the technological developments have been the fastest. And this is why today, this idea of artificial intelligence, which was launched in its more modern sense in the early 50s and has been articulated more specifically in the 1960s, has actually taken off on a mass scale. So artificial intelligence has been around, as I said, for more than half a century at this point, but we have seen an uptick in the development in this arena because of the extended capacities in first the hardware and then in the software development. We have basically more powerful computers than ever before, and this enabled computer scientists to design more sophisticated algorithms. Ultimately, however, the power of artificial intelligence, the power of these algorithms that I am showing you here, goes back to one primary element, and that is data. For some time ago, I think in 2017 or 18, one of my favorite publications, the weekly journal The Economist, had on its cover this title saying, "Data is the new oil." And of course, since then, there have been many critiques of this statement, because while oil is a perishable, non-renewable resource, data, on the contrary, is non-perishable and it's entirely renewable, and it's never-ending also, as opposed to oil, who is about to be extracted in its totality. The metaphor of data as the oil is valid in that aspect, that it does power the new economy. So now making the transition into this idea of AI in the world of business, that what we have also seen, besides the developments in software with the algorithms and the hardware, which is the servers and the supercomputers, is the overarching availability of data. We live in what is known as a datified world. And that means simply that we extract data, we translate activities, behaviors, and objects into data. And once they are transformed into this data, they can be processed through these algorithms, and then computers can actually be, how can I say, be developed and implemented for various purposes. Okay, so let's see if we can move this. How do we know these days if we can see it? And I really like this chart. I don't know if you guys can see it. I'm sure that you will be able to look at this into more detail later on. But with this kind of how can you say, napkin drawing is really very telling. This comes from an MIT technology review from 2018, but it is not, it hasn't lost its validity even in today's 2022 era. So basically, it asks whether you are looking at an artificial intelligence algorithm or not. And this is also the reason why this chart is very important is because when asked, many entrepreneurs, either small businesses or big businesses, so regardless of the business size, whether in the developed or developing world, for lack of a better term, they're having a hard time to identify whether or not they are using artificial intelligence in their own company. And this chart produced by Karen Howe is basically helping people determine whether or not they are using artificial intelligence or whether they are using something different. Yeah. So basically it says here, again, I read it out loud just in case some of you may not see it if you're watching this presentation on your mobile phone, for example. So it asks, can it see? And then it's like a decision tree, right? For those of you who program, you'd recognize this structure. Can it see? No, then it's just the camera. Can it see? Yes. Can it identify what it sees? No, then it's just the camera. Yes. Well, cool. Then it's probably using computer vision and image processing. And then, yup, it's AI. It's using AI. So if it sees, identify what it sees, then it's using artificial intelligence. The same, for example, can it hear? If you answer yes, well, yes, down the line, does it respond in a sensible way? Then that's natural language processing, NLP at work, and yep, that is using AI. Can it read? Is it reading what you type? Does it respond to in a sensible way? If yes, does it transcribe what you say? Then cool, then it's using speech recognition, which is another artificial intelligence capacity. And then the answer is yes. And if you answer no, then it's probably not. So can it see? Can it hear? Can it read? Can it move? Can it reason? Yeah. Can it reason? No, then you start from the beginning. If it doesn't reason, it's not intelligent whatsoever. If you answer yes, is it looking for patterns in massive amounts of data? If the answer is no, then it doesn't sound like reasoning. If the answer is yes, well, the next question, is it using these patterns to make decisions? No, if it doesn't, then it's just like mathematics. If it uses these general patterns that it recognizes into making decisions, then that's machine learning and that's artificial intelligence. Yeah. So I hope this kind of chart will help you all think whether you are watching this as a student or you're watching this as an entrepreneur or you're watching this as a researcher, whether or not you are dealing with artificial intelligence. Yeah. It's about this idea of autonomy and this replication of some of the human capacities to reason, read, hear, and see, which I think is very interesting. So for all this, we need data. And for what we have been through is this kind of datafied and digitalized society. And of course, this is also looking at a very zoomed out picture. We are looking at, for example, Sweden and the Swedish context. We already know that in our country, there is a lot of digital there are a lot of digital services. We have a strong digital environment and infrastructure. This is, of course, in strong contrast with what other countries in Europe and outside can do, right? And it's basically a question that perhaps we can discuss in the Q&A if there's an interest, which is the role of artificial intelligence in perhaps accentuating rather than overcoming what is known as the digital divide. Because in order for artificial intelligence to work, in order for it to be properly implemented and to truly help enterprises and businesses, it needs to benefit from a certain infrastructure. And I already mentioned the presence of software and hardware, in other words, access to computer systems. Also, very, very important, the access to correct and accurate data. It's a whole new, it's a whole thing, thinking about data. I don't want to go into too much discussion at this point, but I'm very happy to discuss this even further. But data is required for artificial intelligence to work. The input equals quality of input equals quality of output, at least in a linear way. And then we also need skills and specialists, right? But in order to perform what is known as the process of automation, this is what I'm showing you in this chart. So what we see here is a progression in the entire, how can I say, from step by step. We first begin at a minute level, at the very bottom of the chart, with something which is called digitization, not to be confused with digitalization, mind you. So digitization is a task, and the task is rather simple, which means that we need to take things that are not data and make them into data, to digitalize them. Digitize. And for example, one of my favorites is to think of all these wearables. Maybe some of you wear a Google Watch, an Apple Watch, a Fitbit, a Garmin. These are wearables which enable you as the individual to obtain information in the form of data about your physical performance. For example, how many steps you have taken, what is your resting pulse, what is your VOC, how well did you sleep, and so on. Quantifying processes that otherwise would be left unseen transforms them into data, and this data can be the basis of algorithms. Yeah, so without this step, there is no further artificial intelligence, there is no automation possible. Digitization sometimes is driven by private actors, like in the case of these wearables that I mentioned. Sometimes it is driven by governments. If we think, for example, as the process initiated by the Royal Library of Sweden to scan and code all the paper newspapers from the 1700s to today, or to transform into a digital file radio and television programs from the 60s, 70s, and 80s. This data, this process enables researchers, for example, to have access to this data. So that was the task. That is the simplest level in the automation process. Then we go to the digital automatization. This is when we allow algorithms to do something with this data. For example, in the case, let's say, of a digital library collection, we allow algorithms to scan the content of newspapers and assign them keywords on the basis of certain word recognition patterns that they have been trained on. Yeah, so this is an automatization process. And this is also slightly more complex, but it's also relatively basic. And what is very important to keep in mind is that this digital section here, the process, can coexist very happily with non-digital processes. Yeah. One example from the business world is invoicing. Here at Lund University, we have adopted e-invoices, so all invoices should be electronic. However, when working with companies outside Sweden, we are sometimes faced with paper invoices. So in that sense, we have two processes, one which is digital, which is faster and more effective, we could argue, but also a non-digital process in invoicing, which is based on the paper system, which requires us to digitize the paper and then input them into the automatized invoice payment system. Once the task and this process are in place, we can proceed to something that many visionaries have talked about since at least a decade back, which is the digital transformation of organizations. This is a very, very ambitious task. And this is something that according to data from the Swedish Entrepreneur Forum, it's not something that we witness fully in Sweden today. And we see actually almost nowhere in the world being fully deployed at a large scale. If we look at the OECD, Japan is the country in which the digital transformation has probably achieved the highest level of maturity. But even then, we are not really thinking about a fully digitalized organization of everything. Yeah. So digital transformation of organization is actually quite challenging for the respective organization because it implies that processes and what is very important also, hierarchies of knowledge are challenged. This is when the entire organization is kind of upended and old knowledge forms are not necessarily discarded, but kind of sidetracked, and new kind of knowledge is amped up. And this is where there's been quite a lot of resistance in this transformation. This is where a lot of consultancies provide specialized services, for example, Ernst & Young, PricewaterhouseCoopers, and so on and so forth. They provide ways that organizations could follow in order to implement this type of transformation of their organization. And what it means that organizations are pushed, first of all, to acquire new personnel with a different set of skills, that they are pushed to reorganize the units composing their organization, and in particular, the relationship between these units. The processes and the connections between these units would have to be different compared to how they used to operate. And this is indeed a task that is complicated and requires a lot of guidance from the management. And there is also quite a lot of resistance from the bottom up. Finally, at the top of this process, and again, I portrayed it here as a linear process, like 1, 2, 3, 4 steps. In reality, as again, some of you who work with artificial intelligence transformation in the everyday would know that this is definitely not a linear process, but that there's a lot of feedback loops across the board. But whether this organization transformation is happening successfully, we could even go to a disruption of the entire industry. And what that means, it means that not only one actor in a specific arena, but all actors in an arena have to recast the way they perform their organization. And one of my favorite examples in here is the movie industry, both in terms of movie making and in terms of the movie distribution. Again, I have a lot of thoughts to share on this, but perhaps it's not so good to take so much time on this. But let me say just simply that here the disruption happens sometimes or most often from smaller actors at the periphery of the industry, who, by adopting new technologies, for example, artificial intelligence, are able to provide better services that respond to new demands from these customers that are more in tune. These newcomers, these peripheral actors to the industry, are able to be more agile and respond more promptly and adopt this technology more rapidly compared to more established actors who don't feel the burn until it's maybe too late. Here we are thinking, for example, of Netflix, who basically disrupted almost single-handedly the movie distribution industry. Soon after Netflix basically a success, other companies such as Amazon or Disney jumped on the bandwagon, but these more traditional actors, traditional in their respective fields, were definitely lagging behind Netflix in terms of home movie distribution. But let me remind you also of something. Netflix existed for a very long time and was not a disruptor from the very beginning. What it disrupted first was this movie renting industry. You would basically rent a movie on a CD, yeah? So it is not this idea of success story of a fringe actor entering the scene and winning big in a movie industry or in any industry is not quite a full story. Netflix had to undergo itself an internal digital transformation of their organization in order to disrupt the entire industry. All right. Now, moving on to something that, again, I think is very interesting to discuss in more detail. If we are indeed thinking about automation as disrupting industries and disrupting the way economic relationships are displayed, then we also must talk about the job replacement theories, which is a topic that has gained probably the most traction in the public, or let's say popular discussion. And this has been brought up already in 2013, I want to say, by a study by a person that used to work at Lund University, actually, Carl Benedict Frey, who basically predicted that in the United States, something like 70%, between 60 and 70% of all jobs eventually will be replaced by artificial intelligence mechanisms, either embodied or or digital. And this, of course, almost started a revolution in the working, among the working people, thinking my job will be taken over by AI. I'm very, very worried. Subsequent research, including by Frey himself, but also by many others, disproved this number, which is more realistically today placed between 6 and 8%. So 6 to 8% of the jobs will likely be disappearing and be completely automatized. Yeah, so we're not definitely thinking about 70% of them being disappearing. Yeah. However, this kind of mindset of what happens when we have an artificial intelligence co-worker has led to all sorts of theories. And one of the theories that I refer to is this one from 2018 by Huang and Rust. I think they use this type of staircase, the staircase of job replacement, which I think makes it very pedagogical. So I hope you agree with me that this is giving you quite a lot of intuition as how this can proceed. So what they say is that artificial intelligence will intervene or will be adopted in an organization by in order to automatize various types of tasks connected to certain type of skills. And the progression is from mechanical to empathetic. I think the names are pretty self-explanatory, but of course, let me go quickly through them. The mechanical tasks and the skills associated with such tasks require quite a lot of routine and repetition. And this is something that has been automatized to a large extent since the 80s. So manual, repetitive tasks have been delegated to the world of industrial robots. And what we are looking at today is a lot of task replacement in what we see as dangerous jobs. For example, again, lifting heavy weights or mining in very precarious conditions or working in a very chemically polluted environment. Yeah, so these are the tasks that have been easily, so to say, accepted as automatized both by robots and by algorithms, like inputting data into a software, like a table. Where we are today is here, when artificial intelligence is beginning to become a co-worker, this type of artificial intelligence colleague in the field of analytical tasks, where there is a data available and there is a routine, a system in place. And some of the jobs that can be associated with an analytical job replacement can be even programming. That we now have software that programs itself, programs more simpler tasks, if you wish. Okay, so that's another example. Then we have what we call soft skills or people skills, which are intuitive and empathetic. And this is where artificial intelligence has yet to really intervene in a meaningful way. Intuitive tasks are those who are based on understanding, so they go beyond data and move on to something called intuition, making an extra step beyond the data itself. And empathetic is based on experience, yeah? When you are basically having this affective dimension. And of course, today we are talking about the affective computing. And this is an area where both computer scientists and other researchers, including from psychology and neuroscience, collaborate to design affective computers. But this is something that is definitely not in the immediate future, probably 50 years or more, even at the current pace of development. Again, we can talk more about this, but I want to be able to go through the entire discussion. And thus, I want to end with this 5 future scenarios. Based on various readings that I have performed about this futuristic science of where will we be in job automation and in introduction of artificial intelligence algorithms in the everyday life, there are 5 future scenarios that describe the man-machine interaction. Yeah, and these are the ones that I will present you here. I hope you can read them for yourselves. But let me just briefly explain what I mean. One is coexistence, which means that we will have artificial intelligence-driven operations and human-driven operations. And when this happens, the side-by-side cohabitation, if you wish, of artificial intelligence and humans at work, then we would have human interaction as the premium and alternative. So, for example, again, it's not really quite that simple, but let's say that you would chat with a chatbot, or you would chat with a human. Now the chatbots are not as sophisticated enough, perhaps, to really give you a true flavor of how it would be to have a more sophisticated chatbot interactivity. But let's say that in 5 years we would have such chatbots, but we will still have a human as well. So if you pay more for a certain service, you could be upgraded to talk to an actual human. Otherwise, you will be serviced by a machine. The same, let's say, with a waiter in a restaurant. You could have a robo waiter, or you could have a human waiter, where the human waiter would be the premium alternative. So the scenario would be cohabitation or coexistence. The second scenario would be that there is a coexistence, a parallel existence, but that humans and machines would be complementary. Humans would perform some tasks and artificial intelligence algorithms would perform some other tasks, but the two would perform in some form of symbiosis, so to say, side by side, but complementary. The third one takes this very classic human-centric view of artificial intelligence, where people retain full control over automatization, and machines will be allowed to take over some tasks or some industries or some jobs that humans don't want to do. As I said before, mining. Mining is a task that is very risky, it's very unhealthy, and is very costly in terms of human costs. So we would happily delegate artificial intelligence robots and the algorithms inside them to do the mining jobs and other things that we don't want to do, like recycling, trash management, and so on. Whereas we would be in charge of something that we enjoy doing, such as teaching, let's say, taking myself as an example. Scenario number 4 is maybe the most futuristic in the sense that it proposes a physical and cognitive integration of humans and machines. What that means is that we would be, again, it sounds very futuristic, but transformed into this kind of androids. One example that I give often is the Neuralink. Elon Musk's, one of the many Elon Musk projects that appear at the time very futuristic, but that may turn out to be realistic. Basically, you would have, let's say, a type of headsets that would be directly integrated with your skull, and that would enhance your processing capacity, the brain's processing capacity. You would think faster and retrieve more information easier with this type of extension. Less futuristic, but something that we know that is happening today. We have these exoskeletons. Of course, they are not deployed en masse, but for example, in physical tasks that require workers to carry heavy things, we have a kind of a suit that is attached to the joints, in particular to the spine of humans, and allows these particular enhanced workers to lift and move much heavier and much bulkier objects, for example. Finally, the 5th scenario, and again, I'm rushing because I want to have some time to interact with you, is the most, let's call it pessimistic scenario, welcome to our artificial intelligence overlords, in which machines completely dominate over humans because humans have simply lost control. Humans have generated artificial intelligence forms that are more sophisticated than themselves. As I said before, we already have software that designs own software. And we have the famous example of 2 computers that basically were trained to learn each other's language, to learn a language. But then they start to speak in a language that the researchers did not understand. So they exchanged, again, language, think about it in abstract sense. They exchanged knowledge, they exchanged information, these 2 artificial intelligence machines, at a faster pace and in a different format compared to the ones that they were supposed to do. And researchers basically could not control the type of information that was exchanged between the machines. And eventually, it ended up with them being unplugged from the wall socket. That's how that experiment ended. And of course, we can imagine a scenario where artificial intelligence will be the ones controlling the electricity supply, and so they could not be unplugged. And what do we do then? And this is the type of fantasy scenario that generates quite a lot of multimedia and literary and video sci-fi work. I stop here, but I want to, of course, recommend you that you should log in on Coursera and check out the AI Business and Future of Work course, because there you will be able to see and hear, besides myself speaking, 12 different experts leading the discussion and the research in this field. And you will have far more pragmatic approaches, including a strategy in 3 steps on how to introduce artificial intelligence in your own company. And I could also just very briefly show you, if I find where I am, maybe the way that the Coursera site looks like. This is basically how it looks. We have 1,000 learners. I'm very happy to see that, and a pretty good rating so far. And here you can read more about the 4 weeks that compose the course. I will stop sharing the screen, and I'll be very happy to respond to any questions. Thank you.
Thank you so much, Anamaria. You are very welcome to send in your questions in the Q&A, those of you who are in the audience. I would actually like to start with the question for you, because I was watching the different scenarios you presented. Is there a preferable one? Some of them are a bit close to the Terminator movie. Is there a preferable one that is actually a society or organizations are aiming for?
I think at the moment, scenario number 3 is what we are looking at, in which the humans retain control. It's a famous phrase among those of us that work with artificial intelligence, the human in the loop. In other words, humans will always be part of the system, either not only just like as the input data, because of course all these machines will eventually work with human-based data, either as the result, as an outcome, but also somehow else, right? But this scenario is the one that is the most desirable, because what we will gain, we would basically gain more productivity, more efficiency, better resource management, and that would, for example, help with sustainability and the environment. And we would also be enabled as humans to be more human, in a sense. I think many people feel, at least this is what the surveys seem to communicate. People are afraid of the machine taking over their jobs. At the same time, research also done on the OECD shows that up to 70% of people do not like their job. 70% of employees find their job meaningless or unsatisfactory. And so having an AI colleague that would take over some of the tasks that apparently 70% of everybody does not like, would make simply humans have more time for themselves, and they dedicate their time to learning, improving their fate, so to say. So I think scenario 3 probably is most desirable from a human point of view, and also something that companies and researchers also work together with companies to design for.
Okay. We have a question here. What part do you think regulation will play in the development and deployment of AI across different jurisdictions and countries?
Thank you for this question. It's a great question. It's also one of the thorny ones, because one of the inequalities that I was mentioning before in terms of digital divide refers also to unevenness in the type and extent of regulation. Here in the European Union, we have a very tight regulations, as in many aspects. The European Union is a leading force in imposing standards, including in terms of ethics of AI. So here, the AI development is constrained quite a lot by what is possible and what is not possible, or what is not allowed, what is illegal to do. Whereas in other countries, and primarily two other countries are worth mentioning, the United States and China, these regulations are far more relaxed. We know from the United States that they are in general more liberal in terms of their innovation. In other words, they allow people to experiment and then regulate if something is wrong. We see the case with social media platforms and the gig economy. Whereas in China, we don't quite know as much. I mean, in China, the biggest problem is that their regulation on paper may look in one way, but the application of that regulation, let's call it the implementation, will be different. So it definitely varies quite a lot. And to provide the sum of my response, I think the regulation is essential, and it probably, the fact that the European Union has a lot of regulatory mandates and a certain standard, which of course is the highest standard in terms of ethics, in terms of transparency, makes it also less friendly to innovation. So the Europeans, if we are to consider this a race, the Europeans are not leading in this race, partly because of regulation.
Yeah. Another question here from Sarah. Thank you very much for the great presentation. I had a question regarding the digital transformation of organizations and how hierarchies of knowledge, as you mentioned, should change. Could you please give an example of that?
Yes, again, there's many examples, but let's take the example that I read because it was quite well exemplified, is in the car production. In the world of car production, engineers used to be focusing on engines, just on engines, and being a good engineer, being the lead engineer at Volvo cars, let's say, would be a person that was very, very good with mechanical engineering and engine and catalyst. Today, we have what is known as smart cars, in which this physical engine is complemented with a true computer. A computer is part of the engine. And so the most valued knowledge today is a knowledge at the intersection of computer science, those who know the computer part of the engine, and mechanical engineering. So the old boss, the lead engineer of Volvo cars, was a mechanical engineer. This is no longer the case. We now have a person that has enough knowledge to understand both mechanical engineering, engine engineering, so to say, and computer science. And so there is some form of resistance from those who came from the engine science purely, who kind of see their position threatened by this more computer science side, yeah? And this is the same, historically, it's a famous example with the horse and carriage versus the car. There was, once upon a time, knowledge about horses was essential for anything from winning wars to being a landlord. But when the car, the gas engine was introduced, knowledge about horse did not disappear, but became very esoteric. So that hierarchy of knowledge was disrupted. And of course, there was a lot of resistance in the 1800s, for example, a resistance to the introduction of the steam engine, of the gas engine, and so on, from people that were not mastering this new knowledge, but were masters of the old knowledge. They did not want to be dethroned.
Great, thank you. I think we're soon running out of time. I know that you're heading off somewhere, but I think we maybe have time for a final question here. Which is the less but most urgent research area to explore within AI in general, and when it comes to AI in the future work?
I'm not entirely sure that I can actually answer this part. I think there's several things that are developed. One of the things that I think is definitely going to happen, because we see the development in some initial phases, is this development of more human-friendly interfaces. So let's call it artificial intelligence algorithms that don't need a programming skill to be interacted with. So instead of addressing them in code, as I was showing you in one of my algorithm pictures, which is a specialized language that people would need to learn, like you would need to learn Japanese, but you would have to learn Python or Java or something else, yeah? Now it's a very good and up and running area that is not yet fully developed, this type of human-friendly interfacing. But also the back end, like designing such sensors, designing such screens, designing such algorithms that allow for this human-friendly interfacing. That would be one of the many answers that I could give you.
Okay. Thank you so much, Anamaria. I thought it was a very interesting presentation, and I think we also got quite a few comments about our audience enjoying the presentation.
I'm very glad to hear. Again, I only want to end saying that if you like this, you can get much more of it and at your own pace looking at this course, and you'll have even more examples for almost all the questions that so far I've been able to answer. So if you are curious about this, you can definitely jump on the Coursera, which is free, by the way, just to make sure that you don't misunderstand. Lund University is committed to free education. So definitely you can access the course and find much more details and many more examples and hands-on exercises to guide you through your thinking about artificial intelligence and the future of work.
Yes, join it. I have already. We will also include the link to the course in our email, also with the link of this recording. But with that, I think we say thank you so much, Anamaria, and thank you so much to our audience, and hope you will have a lovely rest of the Tuesday. Yeah, so have a great
same to you. Thank you so much. Thank you for your excellent questions. Goodbye.
Goodbye.